In example 1, we have a function defined such that f of x equals x squared with a domain of -1 is less than x is less than or equal to 2 and x is in the real numbers. And we're asked to sketch the graph of y equals f of x. So first of all, note that we have a quadratic function. Hopefully you should know the shape of x squared. But we need to draw the graph between -1 and 2. And we also need to know what difference does it make that this is a strictly less than sign and here we have a less than or equal to sign. We'll begin by sketching the curve. And to show we're not allowed the x value of -1, we use an open circle. For the endpoint at 2, as we are allowed to, we use a filled circle. In part B, we're asked to state the range of f. Remember, the range is the possible output values on a graph that's represented by the possible y values. As we've got the graph sketched, this may be easier than if we were just trying to think about it without a graph. So the smallest possible y value is down at 0, and the largest possible y value is up at 4. So we can write the range as 0 is less than or equal to f of x, which is less than or equal to 4. And we should also state that f of x is in the real numbers. Another way we could answer this question is, rather than using inequality here, we can say f of x is in the region 0 to 4, which we can show using set notation. As it can be 0 and 4, we use square brackets. Again, we should also put f of x is in the real numbers. A common mistake with these types of questions is that people forget to use f of x for the range and use x instead. So if you had written 0 is less than or equal to x is less than or equal to 4, you would actually lose marks for that. In part C, we need to evaluate f of 1.5. All this is telling us to do is substitute 1.5 into the function. So f of 1.5 is going to be equal to 1.5 squared, which is 2.25. In part D, it says find the exact solution of f of x is equal to 3. This is saying set the function equal to 3 and solve to find the value of x. So if we've got f of x is equal to 3, that is saying that x squared must be equal to 3. To find x, we square root, and we get x equals plus or minus root 3. However, in the context of this question, because we have a specified domain, we have to be careful about our answer. If we calculate the square root of -3 and get a decimal approximation, we find that it's approximately minus 1.73. But since the lower end of our domain is -1, we can't have x values that are less than -1. Therefore, we can only have the positive value of root 3, which will be 1.73, which is less than 2. So to finish the question, we must say that x is equal to root 3. I don't actually need a positive sign here anymore because the square root symbol we use here actually means the positive square root. Okay, at this point, it would be a good idea to pause the video, copy down the notes, and then have a go at the problem that's paired with this one. Okay, welcome back. Hopefully you paused the video and how to go at this problem pair. We'll now go through the solution so you can check that you've got it right. So starting with the graph of f of x equals sine x, we're told the domain is x is between 0 and 3 pi over 2, inclusive of both endpoints, and x is a real number. So if we think about the graph of sine x, it would normally repeat every 2 pi, but we're stopping at 3 pi over 2, so we shouldn't have any graph that exists past this line here. So drawing the curve, you should have something like this that goes between 1 and -1, and at the endpoints, at 3 pi over 2 and 0, we should have filled in circles because it can take those values. In part B, we're asked to state the range of g of x. I've got the graph over here. We can see the graph doesn't go up above 1 and it doesn't go down below -1. So we can say that g of x is in between -1 and 1 with g of x is in the real numbers. Or if we're using set notation, we could say g of x is in minus 1, 1 using square brackets, and we still need to say g of x is in R. So you don't usually need to write both of these down if you're answering one of these questions, but write both of these ways into your notes now so that you become more familiar with the two ways of describing the range of a function. In part C, we need to evaluate g of 1. So g of 1 means substitute 1 into the function. That's going to be sine of 1. Okay, notice here that your domain is given in terms of pi. That means we're working with this function in radians. So when you're evaluating sine of 1, make sure that your calculator is in radians, and to 2 decimal places you should get 0.84. Finally, to find the exact solution of g of x equals minus 0.5, we replace g of x by the function. So in this case we get sine of x equals minus 0.5. And to solve this, we need to use inverse sine, so x equals inverse sine of negative 0.5. If you put that into your calculator with it in radians, you should get minus pi over 6. Okay, but if we look at our function here, remember our range is between 0 and 3 pi over 2, so this value actually isn't valid. Remember, with trigonometric functions we can get more than one solution by considering symmetry properties and periodic properties of the curve. So in this case, as minus pi over 6 is somewhere over here, the rule for getting a second solution with sine is that sine of my angle is equal to sine of pi minus my angle. So to get a second solution here, we need to do pi minus this. So pi minus pi over 6 gives me 7 pi over 6. So to finish off this question, we've got to make it clear that we're rejecting the minus pi over 6. So we can say therefore x equals 7 pi over 6. Because minus pi over 6 is outside of the domain.